Hi, I'm Divya, and today I'm going to explain you about DAX and its concepts. And first, let me start with what is DAX. So, DAX is the heart of Power BI, which plays a major role to see our visualizations done. So, it plays a vital role in Power BI. And let me give you the expansion of DAX. It is data analysis expressions, and it is basically we call DAX is a programming or a formula language that we use in a Power BI to create a calculated columns, tables, and measures by using different arithmetic operators and different DAX functions. So when DAX works, DAX works only when proper filters or connections are applied to the data model. Like as you all know, like we have fact table and the dimensions table connected on the connected to each other on the data model. So only when the connections are made properly, the DAX begins to work. Let me show you quickly about the connections between fact table and the dimensions table here. So this is the star schema that I have created. Fact table, let me give you the overview of fact table and the dimensions table and why it has been created in this way. So fact table contains measurements, metrics, and facts about the business process, while the dimension table is just a companion to the fact table, which contains descriptive attributes that can be used for used as a query constraining. Okay, so fact table is located at the center of the star schema, whereas the dimension tables are located at the edges of the star. And the connections are made made between these two fact tables and the dimension tables. Why? Because a fact table holds the data to be analyzed, whereas a dimension table stores the data about the ways in which the data in the fact table can be analyzed, and that's where these connections are made to each other. So only when the connections and the filters are applied properly between these tables, the DAX starts to work. So without the proper connections or without proper filters, there is no use of DAX, and you can't. We can't get the visualizations done. So this is the first step to begin with the to begin the DAX. This is the first step and the important step. And this is about the star schema and the general definition of DAX and when DAX can be when DAX can work. So the next concept is like context. So what is context? So context is nothing but it's a layer of filtering the data. Like you can filter the data by using filter the data on the each and every visual interaction. Like you can just filter the data and you can get multiple results out of it. Like it can be recomputed at each and every visual interaction. I'll just show you the example how it works. So here in this example, I have taken a few graphical representations that can show you the results. Okay, so I have here a slicer which has a date range. I have here a scorecard which shows me the total unit cost, and here I have a bar graph that shows me a different kind of channels and the channels and the total revenue over here. So here I have a table which contains date, month, and the channel and its unit cost. So now I'm seeing a figure of 3.35. for the date range in between 1/1/2019 to 11/7/2019, and you see this value. Like when I I need total unit cost for the date range from 1/1/2019 to 10/16/2020. Okay, so now you can see the difference. Like earlier it was 3 million, and now the date, I mean, when you increase the date range, you can see the total unit cost has been increased. So that's what I said, like, it is recomputed at each visual interaction. Like you can get the result like when you change the visuals, when you drag the date here and there, like you can get a different values, which means it interacts to each other, and it gives the result that at each and every interaction that you make. So you can get multiple calculations out of it. And this is one of the way I have shown you. When you increase or decrease the date range, you can see these values. And when you wanted just to see the wholesale revenue alone, like the total cost alone, like when you just click on the wholesale bar graph, you can see 5 million for this date range. When I wanted to check, when I wanted to see the result for the wholesale in between 2019 to 2020, somewhere in 2020, like you can see 3.33 million, similar to same the distribute. If you wanted to check distributors total cost in between 2019 to 2020, I see a different value. So it is getting recomputed at each and every visual interaction. This is how the context works. So this is how you filter the data as well. Like you can filter the data based on this visual interactions. Like you can get a multiple calculations based on each and every visual interaction. So this is the concept of context. And next we're gonna see about calculate. So on calculate, calculate is generally used for arithmetic operations. Okay, so while we perform any arithmetic operations on calculate, the data gets stored and it occupies some storage on it. So under calculate, we have calculated columns and calculated tables. So what is calculated columns and what is calculated table? Let me just explain you calculated column first. So so instead of querying or loading the values into a new column from a different data source, we can create a DAX formula that defines the column value. So with calculated column, you can add a new data to a table that is already in our model. Like you can create a calculated column in a table which is already present in the data model by using some DAX calculations. This is what calculated column means. First, let me try to create a calculated column. Like I can just create a calculated column, yeah, on the regions table. So I'm just clicking on the data view, and I'm clicking on the region table. So now here I wanted to create a column where I can see city and postcode in a single column. I mean, where I'm going to combine these two columns into a single column. So what should I do? Like on the data view, like if you see on the table tools, like you can see a new column over here. Either you can just go to the tools and click here, or wherever you wanted to create a new column, just go to the table and click on these three dots, and you can see new column option over here. Just click on it, and you will be able to see a formula bar on this table. So from here, you can change whatever the name you wanted to give it to the new column. So I'm just giving here city details. So I wanted my new column to be renamed as city details column. And here I have to apply the logic. So what logic I need? I need to combine city and postcode with the separation of comma. So I'm just first I'll just add the first column name, and I'm going to add it. So, and I'm going to separate city and postcode with the comma. So I'm just giving it here, and then adding another column. What I'm going to add combine. So this is the logic that I have implemented to combine city and postcode with the separator of comma. So here you're able to see a new column where it gives city and postcode, and it is separated with comma. So this logic is implemented, and it is, like it is implemented at each and every row, and we and we're able to see the results in the newly created column. And as I said you earlier, the data gets stored. The data gets stored into the table, which is already in our model. So it occupies some storage space. So this is one of the disadvantage on calculate. But yeah, like you can create a column to a table that is already in our model. So this is one of the way that you can create a column over here, and I'll show you the icon here, which has FX symbol here. And I have also created some other calculated column which has a different icon. I'll just show you the difference between FX and sigma. Like you can see here, there is a sigma calculated column icon, and this calculated column has been created based on this logic. So here total cost is being calculated by multiplying order quantity and total unit cost. So it the logic gets evaluated at each and every row, and we are getting these results, and this column has been created. So when you see the results here, all the values are numeric values. So if a field is calculated column with numeric data type, you see sigma symbol here. So this symbol is only for the numeric type. What I created in the regions table is non-numeric data type, which has FX symbol here. So this is the main difference between FX calculated column symbol and the sigma calculated column symbol. So if there is a non-numeric, you'll be able to see FX. If there is numeric values on the newly created column, you'll be able to see sigma symbol over here. This is something, a minute change that I have noticed. So this is how you create a column by using DAX. I have also, let me also show you some other calculated columns that I have created already. So I have created a dates, I have created a column on the dates table where I have calculated by using if function. So what logic I have given here is, if the week number on the dates table is equal to 5, then I need to see the result as true. If not, I need to see the result as false. So when I filter the value as 5, I'll see all the all the result as true, because I have given the logic in a way where the weak number is 5, then I have to see the result as true. If not 5, and select everything, and I'll just select all, and I'll just remove 5, and you can see all the results as false because I have given the logic in that way. So it evaluates, and it evaluates at each and every row, and you can and it gives the results on the newly created column. So this is one of the calculated columns that I have created on the dates table. And also you can see here it, the symbol is fx because the result is non-numeric data type, and hence we are seeing it as a fx symbol over here. So I have also created another calculated column on the sales table where it shows as the range. I have created a logic in a way where if the I have used the if function over here. If the unit price is less than 1000, then I should see the range as low and the rest is high. So based on this function, again, it goes by each and every row, it evaluates it, and it accepts, and it implements this logic and gives us the result in the newly created column. Again, this is non-numeric data type, and hence we are seeing fx symbol over here. Okay, so this is called as calculated column. This is how you create calculated columns. And the next concept we're going to see is calculated table. So similar to this calculated column, right? This calculated table will allows you to create a new table. You know, you might have some tables coming from a different data source, or you might want to create a new table which is just a calculation on the existing table itself. So you can create or embed the logic in Power BI, Power BI itself, and it's called as a calculated table. Like for example, let me just show you how to create a table. And I'm just going into this modeling tab, and you see a new table option over here. I'm just clicking on it, and you can see the formula bar has been created over here, and I'm going to rename it as a demo table. So my table name should be demo table. So I have renamed it. And now what I'm going to do is I'm going to combine two different tables into a single table. So I'm going to choose two tables, customer table, and other one I'm going to combine product tables. So I'm going to combine customer tables and product table over here. So I'm just using the function cross join, where I'm going to join two tables. Like first one is customers, and I'm going to it gives you a hint, like it gives you, like after having the cross join function, it allows you to add table name, and the second one is to be separated with comma. Like then if I put a comma symbol, it gives me a hint to add me second table. The second table what I'm going to add is the product. So it gives me auto suggestion. I'm closing the bracket now, and I'm entering it. Okay, so as you can see on the right hand side, the demo table has been created. Now I'm going to the data view, and I'm going to check if the table has been created or not. So again, I'm going to the demo table over here, and I can see the result. Like it has been, the cross join function has, combined both customer tables and the product tables over here, and now I have a separate table for customers and products. Like I no need to go separately and do some calculations. I don't want to do that. Now I have a table which has two tables into the single table. And this is how the cross join works. So you can add, I guess we can add n number of table names over here. Like let me just try in front of you. Like I'm just gonna try adding a regions table over here. Let me just try if the table, or maybe it shows like the column with the name of index already exists in the demo table. Okay, so the region table has also index over there, and this table is also having index. So let me try changing the name of it. Okay, now what I did is I changed the name of the index in which we have created. So now let me try adding the regions table. I don't know. The column with the name of index already exists in the demo table. So this is the demo table. I don't know. Okay, maybe I have to undo this and check. Okay, let me try to do any values. It's just I'm just trying. Now I'm trying to add regions. Okay, and I'm entering it. Oh yeah. Okay. Now, yeah, you can see I have added the regions table here. Like the error that was showing up previously was the region table also had the index. So the table that we have created demo has also index. So it is understood that the tables should not have same name. So if we have the same name, then we might get that error saying that we have similar names to the table that we're adding to it. So when I renamed the existing column name and then trying to add another table which has a different name, right? So then I was able to combine all the combine the regions table to the demo table. So now you can see the cross join function is able to combine customer table, product table, and the regions table together, and we have a separate table for these three tables. I mean, separate table which has the details of customer, products, and the regions. The only thing is like we should not have same name for all these tables. Like whatever the tables you add, it should not contain the similar names. So that is where we got the error. So let me try another function as well, which is called union. So let me try here itself and check how it works. So I'm just okay. Each table argument of union must have the same number of columns. Okay. So what I understand from this error is the union function will work only when the table have similar number of columns. So obviously this region has too many number of columns. So I'm just removing the region table from here, and I'm trying with these two customers and products table, and let's see if it is working. Yes. So the customer and product has equal number of columns, like two columns it has. So let us check here. So the customer has two column over here, and the product table also has two columns, and that's why the union has accepted these two tables to combine it. And I can see the difference, like the union has combined it, but it has added the other table below the first table. So whereas the cross join was adding the table side by side, but the union is adding one by one, one after the other. So, okay, so this is how union function and the cross join function works. And this is how we create a new table. Yeah, and also I just wanted to show you the icon of the table. So this is how the table icon will be. So yeah, so this is how we create a new table. And the next concept is measure. So measure is also used for a similar kind of arithmetic operations. Measures are created and displayed in a report view or the data view. And measures you create in the fields with calculator icon. Like I'll just show you, get into this. Okay, so I have already created some measures over here, and you see all the icons are created, and it is completely, you can see it is all calculator icons. Like measures you create, appears in the field, which is with calculator icon. You can name it as per it's our wish. We can whatever the name you wanted to give, you can just give. And I'll also let you know how do we create it. Like in this report view, you can see new measure over here. You can just click on it, or else if you just create have just created a measure under the customers table, and you can see a measure that has been created over here with a calculator icon. Like if you want it, like you can rename into anything, like any kind of thing, like demo or whatever the name you wanted to give, you can just give it, and it creates a measure over here. Okay, so I have already created some measures over here, and I'll just explain it, what is what and everything. So measure has two different concepts under. So one is aggregator functions and iterative functions. So aggregator functions will give you, the summarizations. Like it will give you a granular level of details. For example, I have created, I wanted to see the average sales. So what I did is, like I have given this DAX function. So the main difference, between aggregative and iterative is, aggregative is it's a simple summarization that goes, at the granular level of evaluation will happen on the aggregative, whereas in iterative it performs, it evaluates each and every row. And also there is a small difference in the formula where you can see where I show you the difference. In aggregator, we use sum, average, min, max, and count. And whereas in right now I'm showing you the aggregator function, which has only the average function here. In iterator, let me just show you the iterator. Yeah, in iterator, you can see the function has been returned with the x. So this is one of the main difference between aggregative and iterative, where we use x after each and every function. So this is iterative, and this is aggregative function. So here I'm just calculating the average of total revenue. So I'm getting this value here. Whereas in iterative, like I'm giving a logic called average x. Also here I have written the table name first, and then the column name, and the arithmetic, whatever the operation I wanted, I have just mentioned here. So here I wanted to calculate average by multiplying order quantity and the total unit cost. So I have just given this arithmetic operator, and then I'm giving the second column name, and then closing the bracket, and then I'm performing this. So this logic will be applied to each and every row on the sales table, and then it gives me the result. So here is the iterative thing. So the average X, so average total sales has been calculated, and then I'm getting the result as 12,194.49. It it iterated on each and every row, and I got these value. So similar to this, we have for sum X, for minimum min X, maximum X, and the count. Okay, so for the maximum, similar way. Okay, let me show you here. Sorry. So on the aggregative, we have average. So max, I have minimum. Okay, so on the total sales sum. Okay, so whereas in iterative, it is max X, and particular logic, whatever the logic. So average, for average also I have already shown you the logic, and min X and the sum X. So this is a slight difference between aggregative and iterative. Aggregate gives you the granular level of information, whereas iterative goes each and every row and calculates it and gives you the accurate result. And also the main difference is in the logic, you can see, I mean, on the function you can see X along with sum in iterative, whereas in aggregative you won't see the X over here. So this is one of the major difference between iterative and aggregative functions. So yeah, thank you.